Okay, so we are doing very similar to yesterday's video. We're going to be subtracting mixed numbers again. I'm only going to change one denominator. So we'll do two methods again, just to remind you, two different methods, but they will get you the exact same answer. So I'm going to half our board for our two different methods. So the question we're going to do today is we're going to do 3 3/7 subtract 2 5/14. That's going to be our question. I'll just write it over here ready. So we're going to do two different methods and you do the method that suits you. So method number one over here. I'm going to do my, who should I start with today? I think I'm going to do my improper one today. So the one we've been doing for a little bit longer. So I'm going to convert the mixed numbers into improper fractions. So 7 times 3 gives me 21. 21 plus 3 will give me 24 over 7. Then if we pop over here, 14 times 2, so a slightly larger number now, but 14 times 2, well that's 28, and then 28 plus 5 would give me 33, and we'll keep that over 14. So now all we need to do is we need to make this fraction here over 14 also, because I know that 7 and 14 both appear in the 7 times table. So I'm going to pop 14 down here. Well, I know 7 times 2 is 14. So I've now got to do 24 times 2. So we can double that, and 24 is quite a friendly number that we can double, but equally you can always do, you can add them together, or you can do the column method, whatever you'd like to do. So I'm going to use my head today for this. So I know if I double 24, I would end up with 48. And then we can keep this one over here the exact same because it's over 14. Like so. So now I need to subtract these numbers. So we'll keep our denominator the same. Now, 48 take away 33, slightly bigger than what we may have done previously. So if you can do it in your head, that's brilliant. You can equally do a little column subtraction. I'm just going to pop a little column subtraction up here to show you. So 8 take away 3 would give me 5, and 4 take away 3 would leave me with 1. So I can now pop my 15 over here. So I've now got 15 over 14, very close to being 14 over 14, which would have been a whole. And actually with that in mind, I know that I'm actually going to have one whole down here. And because I know that 15 is actually 1 away from 14, I know there's only going to be 1 left over. I'm going to end up with 1 and 1/14. So that's method number 1. Method number 2, similar to yesterday. So I've got, if I just look at the fraction part of this question, I've got 3/7 and I've got 5/14. So if I can make this part of my question over 14, should make my life a whole load easier. So I know that if I double 7, I would get 14. And whatever I do to the bottom, I do to the top. So I could actually rewrite this fraction here as 3 and 6 over 14, because 7 times 2 is 14, and 3 times 2 is 6. And then I keep this part of my fraction the exact same, and it just makes it completely so much simpler to work with. So we'll just look at the fraction first. So I keep my denominator as 14, And I know that 6 take away 5 would leave me with 1. And that 3 take away 2 would also leave me with 1. And then you can see that over here I had 1 and 1/14, and here I have 1 and 1/14. So both questions are giving me the exact same answer, 2 different methods. This one was an awful lot quicker, but this method also works. And maybe when you start ending up with very large fractions and all sorts of denominators, you have to see the method that suits you, but either one would work.